ABC is a triangle. D is a point on BC such that AD is perpendicular to BC. E is a point on AC such that BE is perpendicular to AC. AD and BE intersect at this point O. Prove that angle DOC equals angle DEC. Angle DOC is this angle here. The letter at the center is the corner or vertex of that angle. The line DO is one of the arms of the angle, and the line OC is the other arm of the angle. Angle DEC is this angle here. Again, the letter E, the letter in the center, is at the corner of the angle, or the vertex. DE is one arm, EC is the other arm. We want to prove that these angles are the same. Now the way I will prove this is to, first of all, prove that there is a circle going through points O, E, C, and D. Of course, through any 3 points we can draw a circle. But I'm going to prove that the circle through, say, these 3 points here actually passes through this 4th point. So basically I will prove that the quadrilateral DOEC is a cyclic quadrilateral. So here is the quadrilateral DOEC. A cyclic quadrilateral is a quadrilateral or 4-sided figure that can be drawn inside a circle. So it's 4 corners or vertices lie in a circle. Now the way we will prove that these 2 angles are the same is by seeing that they stand on the same arc of the circle. They stand on the arc DC. DOC and DEC stand on the same arc, and that means they're equal angles. So the first theorem I will use is the following. If we have a quadrilateral that is a 4-sided figure whose opposite angles sum to 180, so A and B are a pair of opposite angles, and we're saying that A plus B equals 180. So we take one pair of opposite angles. So we could either take this pair or we could take these 2 angles here. Doesn't matter. Well, if this is true, then this quadrilateral is cyclic. So that means a circle can be drawn through the 4 corners of this quadrilateral. By the way, if one pair of opposite angles sum to 180, then the other pair of opposite angles also sum to 180. So if this happens to be x and this is called y, then x plus y is also 180. So we only have to show that one pair of opposite angles sum to 180. Sometimes these are called supplementary angles. So A and B are supplementary angles. X and Y are also supplementary angles. So why is it true that if one pair of opposite angles are supplementary, then the other pair are also supplementary? Well, the 4 angles add up to 360 degrees. So if A and B add up to 180, then X and Y, X must add up to 180 also. So this is one result that we will use. I proved this result in another video. I won't prove it here. A second theorem that I will use to prove this problem is that if we take an arc of a circle and look at angles standing on the arc, so the arc of this circle is shown here in purple. So take an angle that stands on it. That means take any point on the circumference and join that point to the end points of this arc. Then this angle here will be the same as any other angle that stands on this same arc. So if we take any other point, say I take a point here, and join it to the endpoints of this arc, then I get an angle here, another angle formed. These 2 angles stand on this same arc, and they're equal. So this is another theorem that I prove elsewhere. I won't prove it here. If I call these 2 angles M and N, then we see that M equals N. So now to prove that angle DOC equals angle DEC, we start by noticing that the quadrilateral DOEC has opposite angles that sum to 180. We notice that angle ODC, which is this angle here, plus angle OEC, which is this angle here, sum to 180 because they're both 90-degree angles. 90 plus 90 is 180. So that means that the quadrilateral DOEC is a cyclic quadrilateral. So that means that we can draw a circle through the four corners of it. By the way, if ODC and OEC sum to 180, then the other pair of opposite angles also sum to 180. So angle DOE, which is this angle here, plus angle DCE, which is this angle here, must also sum to 180, because the four angles in a quadrilateral sum to 360 degrees. But we don't have to look at those two angles. The next thing we noticed, as I mentioned earlier, is that angle DOC and angle DEC stand on the same arc. They stand on this arc of the circle. So if they stand on the same arc, they're equal by our second theorem here. So in this problem, there is some redundant information. We don't need the line AB or BD or BO. We just need to look at the quadrilateral DOEC. In the triangle HKT, angle KHT is 90 degrees. So where is angle KHT? Well, the letter in the center here is the corner or vertex of that angle. So the vertex must be at H. One arm of the angle is KH, so this is one arm. The other arm is HT. So the angle lies between arm KH and HT. So this angle here is 90 degrees. We are also given that the line HP is perpendicular to KT. Prove that the two triangles HKP, which is this right angle triangle here, and HKT, which is the large right angle triangle, are equiangular. Equiangular is another word for similar. Similar means equal angles. We also want to write down two ratios equal to PH divided by PK. It's PH over PK. So here are the two triangles, HKP and HKT. Notice that they have this side in common. So I've indicated it here in red. Notice also that they have this angle in common. This angle is the same in both. I'll call it X. So we see that we have two angles the same in both triangles. So that means that the third angle, or remaining angle, is automatically the same in both triangles. So I'll call the remaining angle Y. So that answers the first question. Angle HKP, which is X, equals angle HKT in the large triangle, because the two triangles overlap at this corner here. And we have that angle HPK, this angle here, equals angle KHT, which is this angle here, are both 90 degrees. That was given. So if two angles in it are the same in two triangles, then the third angle is automatically the same. So that proves that triangles HKP and HKT are equiangular, or in other words, they are similar. Now, since these triangles are equiangular, let's look at corresponding sides. So I've highlighted in blue the sides that correspond to angle X. So they're the sides that are opposite angle X. And what I've done is I've looked at this triangle first and put the blue side belonging to it PH over the blue side HT in the larger triangle. Now look at the sides corresponding to angle Y, KP or PK in the small triangle and HK in the large triangle. So we take the sides corresponding to Y in the small triangle, which is PK, and put it over the side corresponding to Y in the large triangle, which is HK. So the side belonging to the small triangle is in the numerator, and the side belonging to the large triangle is in the denominator. So we have to get the sense of these ratios correct. Finally, we take the side corresponding to the right angle in the small triangle. That side is HK, and the side corresponding to the right angle in the large triangle is KT. So we take HK and divide by KT. So we have three ratios here that are equal. So this is a theorem that I prove in another video. I won't prove it here. Now we're interested in the ratio pH over pK. Now pH over pK doesn't appear here, but we can do some rearranging to get pH over pK. Specifically, we look at these two ratios and rearrange them. If we take this equation and cross multiply, we can do that because we have just one fraction on each side of this equation. We get this here, pH times HK equals pK times HT. Now we're interested in pH over pK, so how do we get that? Well, what we do is we divide both sides of this by pK, because we want to get pK underneath pH, but we also want to get rid of this HK. So when we do that, the HK's cancel out on the left hand side, and on the right hand side the pK's cancel out, and we end up getting pH over pK equals HT over HK. So HT over HK is one ratio that is equal to pH over pK. Another way to arrive at this is to multiply both sides of this equation by HT to get rid of HT in the denominator, and then divide both sides by pK. Now the result of doing all of that would be to interchange HT with pK. If we swap these around, we get pH over pK equals HT over HK. That's a quick way of doing it. Now we are interested in two ratios equal to pH over pK. So where is the second ratio going to come from? Well, it's not going to come from looking at these two triangles. We don't have enough information.